Assalamualaikum to our respected lecturer, Dr. Rahaiza, and our fellow friends. We are microbiology students from 2A7 and we are here to do a presentation for our group assignment. To begin, we are going to introduce ourselves first. That consists of 4 members, that is Ain SOLEHAH, NURAINA, IZZAH AFIQAH, and ALYA SYAZWIENA. Our assigned topic is gravimetric analysis. We are going to explain to you guys about the contents that contain in this topic. First thing first, gravimetric analysis is a method in chemistry to measure the amount of a substance by weighing its precipitate after a chemical reaction. First, the substance of interest is made to form a solid precipitate by adding a specific reagent. This solid is then separated from the liquid using a filter, washed to remove impurities, and dried to eliminate moisture. Finally, the mass of the dried precipitate is measured accurately using a balance, allowing us to calculate the amount of the substance in the original sample. Gravimetric analysis is a precise and widely used in various fields like environmental testing and drug development, offering reliable results when other methods might not be suitable. The principle of gravimetric analysis is based on the estimation of the mass percent of an ion in impure compound of known quantity by determining the mass of the same ion in a pure compound. In order to determine the mass, the ion of interest needs to be completely isolated. This isolation of ion is done with the help of precipitation. Typical procedure used in a gravimetric analysis include making a solution with a known amount of the simple analyte, separation of the desired ion or element or radical in pure forms by various separation methods. After the ion has been separated, weigh the amount of the pure insoluble compound form, calculating the value of the individual compound of interest based on the weight of the compound observed. There are 4 main steps in theory for gravimetric analysis. First, form a precipitate by adding a chemical to the sample that reacts with the substance you want to measure, forming an insoluble solid precipitate. Second, filter and wash, which separate the solid from the liquid by filtering it, then wash the solid to remove impurities. Third, dry and wait. Dry the solid completely to remove any water, then weight it accurately. Lastly, use the weight of the solid and the non-chemical relationship to calculate the amount of the original substance in the sample.
There are 2 types of gravimetry analysis. The first one is precipitation gravimetry analysis. So precipitation gravimetry use a precipitation reaction to separate one or more parts of a solution by incorporating it into a solid. There are 4 styles of precipitation gravimetry. The first one is analyte is converted to a sparingly soluble precipitate. Then the precipitate is filtered and washed free of impurities. Then it is converted to a product of non-composition by a suitable heat treatment. Then the product is weighed. The second one is volatilization gravimetry. Volatilization gravimetry involves separating components of our mixture by heating or chemically decomposing the sample. So there are 2 steps in volatilization gravimetry. The first one is analyte or its decomposition products are volatilized at a suitable temperature. Then the volatile product then collected and weighed, or alternatively, the weight of the product is determined indirectly from the weight loss of the sample.
Now we'll be explaining about the methodology of gravimetric analysis. The systematic steps involved in determining the quantity of a substance through the measurement of the mass of a precipitate formed. Initially, the sample must be appropriately prepared, ensuring it is in a suitable form, either solid or in solution. Solid samples are ground into fine powder, while solutions undergo filtration to eliminate impurities. Subsequently, the sample is dissolved in a suitable solvent, sometimes necessitating heat to achieve complete dissolution. Following dissolution, a specific reagent is introduced to precipitate the analyte of interest, forming an insoluble compound. For instance, the addition of silver nitrate facilitates the formation of silver chloride for chloride determination. Once the precipitate is formed, it undergoes a digestion process, allowing it to age, thereby increasing particle size and enhancing filterability. This step also serves to purify the precipitate, ensuring accurate measurement of its mass. Next, filtration. After digestion, the precipitate is separated from the solution via filtration. Several filtration methods are available, including gravity filtration and vacuum filtration. The choice depends on the nature and volume of the precipitate. The filter medium, often filtered paper or a sintered glass crucible, must retain the precipitate while allowing the liquid to pass through. Next, washing. To ensure the purity of the precipitate, it must be washed with a suitable solvent that does not dissolve the precipitate but remove any soluble contaminants. For instance, in the case of silver chloride, washing with dilute nitric acid can help remove any absorbed impurities. Next, drying. Once washed, the precipitate must be dried to remove any moisture. This is often done in an oven at a specific temperature. In some cases, ignition is required to convert the precipitate into a more stable form. For example, calcium oxalate precipitate is ignited to convert it into calcium oxide. Next, weighing. The dried or ignited precipitate is then accurately weighed using an analytical balance. The precision of this balance is crucial as it directly affects the accuracy of the analysis.
The result of gravimetric determination usually is reported as a percentage of analyte. To calculate the percentage of analyte, two values are needed, which is the weight of the analyte and the weight of sample. To calculate the weight of analyte from the weight of the precipitation, a gravimetric factor is used. Gravimetric factor is the weight of analyte per unit weight of the precipitate. Here is the example of the calculation. So, to determine the percentage by mass of calcium in the limestone sample, we must ascertain the amount of calcium in the 2.43 gram of precipitate form. We know the molar mass of the calcium oxalate is approximately 128.1 gram per mole. Okay, so now we calculate the mole of calcium oxalate in the sample. It equals the mass of the precipitate divided by the molar mass of the calcium oxalate. So the moles of the calcium oxalate is 0.019 moles. Each of the formula unit of the calcium oxalate contains one atom of calcium. Therefore, the moles of calcium are also 0.019 mole. The atomic mass of calcium is 40.1 gram per mole. Hence, the mass of calcium in the sample is 0.019 mole times by 40.1 gram per mole equals to 0.76 gram. Finally, the percentage by mass of calcium in the limestone sample is the mass of the calcium divided by the total mass of the sample, multiplied by 100. So, 0.76 gram over 2.00 gram times 100, which equals to 38%. Therefore, the percentage of calcium in the limestone sample is 38%.